Hello.
Hi.
Hi, how are you?
Okay. I may not be able to participate that much here, but I'm going to try. It's kind of a public space, but
Okay.
I'll be for a short time.
All right. Yeah, that's good. I was just wondering if you wanted to give any updates or anything. I know we were gonna have a discussion about some things, but
I don't have any major updates for like the New York Celebration of Limit computing stuff. There's progress on that, but I don't. It's not really easy for me to show right now, so I don't have the means to do that. If anything, I would maybe just have a short discussion about the market stuff or any of our other papers or other stuff that, like I could talk a little bit about the like the embodied workshop, but I don't know how that fits into your agenda otherwise.
oh, we could start with the embodied workshop or embodied intelligence workshop, and then we can talk about the Marcus stuff. So why don't we do that? Actually, why don't I go through a couple things here before we start? I'd just like to bring people's attention, if you're watching on YouTube, to the, and this leads into the Embodied Intelligence Workshop, the new blog post that I put up on the Medium. This is medium.com Oral Group. And it's right here, this EAI workshop and recent Saturday morning NeuroSim conversations. And I was having actually a little bit of trouble with this.
Are you trying to share your screen?
Oh, are you seeing the screen? Yeah, let me share it. Okay. So, this is the EAI workshop and recent Saturday morning NeuroSim conversations. So I had a little trouble with this post. It was there was some technical glitch. So if you looked at it earlier, it may not have loaded, but it's loading now. So this post kind of covers our involvement in the Embodied AI workshop. So this is next week, and you can register for free at this link, which is eiworkshop.org. And so we actually have three people from the lab group presenting. We have myself. I'm going to give an overview of developmental AI. Jesse is going to give a presentation on the cognition future stuff, a decade in review, computational modeling of embodied cognition. And Stefan Dvoretsky, who's not joined us in the recent past, but he was a GSOC person in the lab last year, or the year before, 2019. And he actually worked on the Bratenberg vehicles. So he modeled neural development in Bratenberg vehicles, and he's going to talk about that. I'm going to talk about approaches to developmental embodied neurosimulation, which is basically kind of an overview of the developmental AI area. And then Jesse that's going to be on Thursday, March 25th at 12 p.m. GMT, which is about 8 o'clock in the morning on the east coast of the U.S., and right around noon in Europe, and in the early afternoon in India. You'll have to check your time. So that'll be interesting. Then Jesse will be presenting on Wednesday, March 24th at 17 GMT, which is about maybe 10 or 11 in the morning on the East Coast, maybe 11. I don't know what the actual time is, in the late afternoon in Europe, and then in the evening, late evening in India. Again, check your time change or your time schedules. So that should be a good time. We're really kind of hitting this group hard. We just want to get our ideas out there, so that's good. It looks like a lot of good stuff at that meeting, and I have the agenda. I can go through it later. There's a lot of good stuff there. And then in this post, I also talk about some of the discussions we've had in our past meetings. So there's the March 6th meeting where we talked about Bayesianism, cybernetics, and connectionism. And so this is, and I found a way to link to specific points in a video, actually. So if you click on this video, it starts just before the discussion, and it'll lead you through the discussion. So check that out. This is a screenshot from the discussion. And then the second discussion is from March 13. This is linguistic change and theoretical change in interdisciplinary science. This discussion talked about like the neuroscience and cybernetics relationship, and then talking about the idea of Darwinian natural selection being this thing that evolved, and maybe it was inevitable, maybe it was an idea that would have come to us eventually. We kind of like left that hanging. So, if you're interested in that discussion or the other discussion, again, link on this. This will take you right to the talk, or right to the point where we start discussing it in the recording. And then if you have anything like insightful, please talk about it in the Slack, or we can talk about it via email, whatever. I think this is a good topic to follow up on, but I don't know what people are getting out of it. So I'd encourage people to share their thoughts on that. And so these are the further readings here.
Yeah, this is a very good summary of a lot of things from the workshop to the last two. Those two conversations are important, and I'm glad they were sort of given the context that they are there, and I think we'll be referring back to them a lot in the future.
Yeah, we might think about doing that with some of the other discussions in the past. When I put the YouTube videos up, I give a description, and so I know I've been tracking through that mechanism some of the discussions, and so I might go back and even kind of mine some of the past discussions even before this on different things, and we can bring them back to the surface. I think that's a good way to do it, because these discussions get lost, and they shouldn't get lost, because they're things we can build upon for future activities. I think I also have the I don't know if I have it in here. Maybe I'll have to go to 320. I had the papers for today in here, and I think I was in the wrong place. Here it is. I have the workshop program. So this is the workshop program here. You still see my screen?
Yes.
Okay. So this is the workshop, EI International Workshop, Embodied Intelligence. And this is on the 24th to the 26th of March. So this is this coming week. 24th is Tuesday. 26th is Friday. So it's all week. And they have a number of, they have a lot of people talking here. But they have a lot of, short talks and panel discussions. They have a plenary talk by Carl Friston on Tuesday. They have... looks like a panel with Andy Clark on Tuesday morning. Some other panels here. Some people, you may have heard of some of these people, you may not have, but that's why they have these events, so you can see the names that are, big in the field. And then they have these breakout sessions, which are, of course, the ones that we're going to be involved in. And they have a lot of good topics. Cognitive developmental robotics, beyond bio-inspired robotics and control. It's something they call open crazy topics, which is something that that's what Stefan and I are doing. So, I don't know if our approach is a crazy topic, but I guess this is what they couldn't fit into any of the other panels. So, it looks like there's some good stuff on, good stuff in some of these breakout sessions. Kinds of intelligence. This is Jesse's panel. So it looks like there's a lot of interesting embodied type stuff here, with talking about affordances and spiders using regenerated legs. There's a lot of stuff here to kind of check out. As far as I know, it's being run through a Zoom link. So you have to log in, you have to register, and then they'll give you the login link. And I don't know if they're going to be recording these. I kind of hope so, because I can't make all of them. I know. So I don't know. I'd like to see some of these, but I don't. Yeah.
Yeah, same.
So, so check this out, definitely. And then I think that's all I have on that workshop. I actually have one more thing I wanted to announce early here. So there's this open-ended challenge. We've talked about open-ended evolution. This is in Minecraft. So there's a Minecraft open-endedness challenge. And this actually is connected with the embodied intelligence stuff because, we talk about intelligence, we talk about like machine learning, and then we go on to deep learning, and we go on to maybe reinforcement learning. But this is more about like digital evolution and genetic algorithms and using those to evolve what they call open-ended systems, which are these systems that don't have a goal necessarily, but they evolve, adaptive capacities and other things that allow them to adapt. And so you can think of a lot of things in social systems and in biological systems that behave like that. And so they're actually looking to, this is kind of like a Kaggle challenge where you have this competition amongst people who enter, and they have to put an entry in, and the best person wins prizes. I mean, the best entry, not necessarily the best person, wins prizes and other things. This is being sponsored by Gecko, which is the Conference on Genetic Algorithms. And so this will be, if you're interested, I don't remember what the URL is. I think I've tweeted it on the lab account. So you can always, put this into your search engine and see what it comes up with as a link. So I wanted to get Jesse's take on some of the his progress on the embodied intelligence front.
I haven't really done much of this yet. I'm currently, away this weekend, so I'll be thinking when I go back mostly.
Yeah.
But I like the comments a lot, and I'm looking forward to. I don't think I recorded myself.
Okay. Yeah. Yeah, I know.
In general, I guess I should say that my project is kind of inspired by kind of a state of the state paper from 10 years ago by Zulo, and I'm kind of just going to go it's 3 minutes of a flash talk, so I'll kind of like give an overview of that paper, maybe, or at least mention it, and then kind of talk about the trajectories that have developed since then. That's kind of the plan for my talk.
Yeah. That's good. Yeah, it's very tight. So I have to figure out how to approach it. I have some slides that I haven't changed them since I last showed them in the meeting. So if I share my screen here, I can go through them a little bit. So this is, again, the roadmap for Developmental AI. This is, I've updated this since I've shown it to the group last. This is where we have all the different components that might be involved, and then the papers that are attached to this. So, Developmental Brainward Vehicles, that paper was put out last year. Continual Embodied Learning, this is the thing we submitted to A-Life, but it's also on the archive now. Dynamical Heterochrony, which is this paper that I haven't really talked about in this group, but it exists. It's on heterochrony, which is changes in the timing of different developmental events. And if you look in this literature, you'll see that there's a lot of stuff that is, it's basically operates on this idea of a scaling law. So you have these scaling laws that predict heterochrony, and then the slope of these scaling laws change over evolutionary time, and it gives you different timings in development. So, your head starts growing at point A, your head stops growing at point B, and your head is a certain size. as the outcome of development. But what happens often in development is those windows are opened up, or they're closed, or they're shrunken, or the rate of growth is lower. So that means that first of all, the onset of your growth starts at a certain time. Maybe it's earlier, maybe it's later than your common ancestors. The offset of growth, which is the time you stop growing, is earlier or later than your common ancestors. And the rate of growth is different. So you end up with something that is either larger or smaller than your common ancestors. And so this goes for head size, this goes for body size, body length, all different types of components. So you can use heterochrony to model like growth processes, but you can also tie it to the critical period, which is this period we talk about with respect to when things are acquired most easily, or when things proliferate most voluminously. So we can fit that into the scheme. We have our metabrain models. We have training on viewpoint networks, which is this open review paper. We don't talk about this directly in this paper, but this is the closest thing we have to a paper on this topic. We have the allostasis machines paper, which was accepted to emergent interaction, and that this is something that we're going to need to turn our attention to in the next couple weeks, because we have the camera ready version that's due, I think, April 11th, and then the presentation, which is due a couple days later. So it's a 15-minute presentation. I'll start the slides off probably this week, get it into some sort of shape, and then record it, and then submit the recording to the workshop. And we'll I think the way they'll do it is they'll air the or have the video as part of a collection, air it during the workshop, and then we'll be asked questions. Whoever in the group is there at the meeting, they'll ask questions and have a discussion. So that's coming up. And then there's ANN BNN's paper, which was the thing that was submitted to AWIFE as well. And it's I think it would fit into this roadmap quite well. It's a new edition, but I think it'll be something that can be added into the whole pantheon of things that we're talking about here. We go to the idea of developmental time, so I talk briefly about this. Then I talk about Gibsonian information. I mean, this may be a bit too much for 3 minutes. I'll have to think about how to shrink this down a bit. Maybe I'll just talk about this slide here instead. This is where you have this rabbit, and there are different components to the sensory inputs, and they're either congruent or they're incongruent, and then that's your Gibsonian information. And I've been thinking about this more this week, so I might add some things into this slide that are not the way it's currently designed, is not the way I want to approach it necessarily for this group. So I might change that around. Then talk a little bit about allostasis machines. And then this architecture for developmental innateness, this fits into the developmental Bradenberg vehicles. Now, I didn't know that Stefan had submitted something in Bradenberg vehicles, so it was to my delight that he had submitted something and got it in. So this is like, I don't want to get too deeply into this, and I just wanted to point this out. It's interesting because we're sort of sequential in that breakout room. So he gives his talk on developmental Bradenberg vehicles, then I can talk about this, and at the end I can call back to the Bradenberg vehicles and say, recall the Bradenberg vehicle, and then we can talk about sort of this general architecture, which is, from what I've seen from his slides, he doesn't really talk about this process too much, which is the sort of the generative process of building like cells and connections within the vehicle itself. And so that's what this slide is. This is from this continual embodied learning paper, which basically gives some, it's sort of a technical description of how to arrive at some of this network growth internally. So, and then this is the idea of these cells being born and dying sometimes, and then their activation strength over developmental time. So this is encoded in a linear genome. This is what gets produced by this element here. It's mapped to these different cells, and then they're turned on and off, and turned on at a certain rate or a certain strength, and then this graph is summarizing this. So I think I can do that in 3 minutes. I'm not entirely sure, but I'm going to probably try to optimize it before I do the talk a bit. So, Jesse, any thoughts on that?
No, but it looks good. I think it'll be complementary Stefan's work. And I'd like that the slide ended on sort of developmental readiness or towards architectures for developing that. I think that'd be intriguing to think about.
Yeah, definitely. So looking forward to that workshop. And then I don't know if Envision is coming up soon. I thought it was. Am I mistaken, or?
What?
When is Envision happening?
April 9 and 10.
Okay, so we have a little bit more time on that. Okay. I was just trying to time it out in my mind, and I couldn't remember exactly when that is. So, that's good.
Yeah, it's actually the same weekend as the U.S. Celebration of Women in Computing, which is a little bit difficult, but that's okay.
Yeah. Okay. All right. Well, that's good. Did you want to give more of an update on the New York Celebration of Women in Computing?
No, I don't have a lot of good ways to do that right now. Other just to say that the slides are coming along, and there's a document that's being worked on.
Okay. Are there any problems, or do you need any help with anything?
Not really.
Okay. All right, so that's good. Let's see. Why don't I move on to the Slack review now? Let me go back to sharing my screen. And so this is a Slack review. We do this on a regular basis so people know what's in the Slack. This is I kind of opened it up to the aging channel. Nothing has been happening in here recently, but just to let people know that there is an aging channel. We've talked about aging things in the past, different topics or papers. We haven't really put in too much recently, but that's something if you want to get involved in. Brain organoids is kind of been silent for the last month, but hopefully we'll get back to that pretty soon. We're kind of focusing on different things. So right now we're focusing on the developmental AI stuff, and and maybe we'll focus on the epistemological directory soon. But for now, we're not really talking about brain organoids that much. But we're going to turn back to that eventually. The Brainberg Vehicles channel kind of talk about. Rashab was talking about. He's kind of caught up on the paper on the embodied continual learning paper. He's excited about it. Him and Daniela had some things to say about it. Morgan has posted a couple of things in this channel here. This is old. This is fairly old. So this is Brainberg Vehicles channel. Calls for involvement. We haven't really used this channel very much. Maybe we'll start using this more. Let's see. Cognition futures. Is there anything new here? Looks like nothing really that new. We just had this Gary Marcus tweet that was something that we had from a couple weeks ago, and it's my understanding that Jesse, he wanted to discuss something about Gary Marcus. I can't remember. We can talk about that after the Twitter review, or the Slack review, though. let's see, that's collaborations, that's old conference materials. So we're coming along. We're keep checking these conference channels and submissions channels for more information. Cybernetics maybe has some information. Well, not much really. This thing from Norbert Weiner's book on information, language, and society, Jesse put up. It's a interesting quote here.
Yeah, there was a particular reason that came up. Man, I don't want to go into it now, but essentially it has to do with Norbert's concept of thinking about broader systems. And I think the quote, I think everyone can't see it right now, but yeah, it starts off with, one of the issues in the books. The first line in the whole thing, you go to the top of the book, it shows, it's held together by this means of acquisition, use, retention, and transmission of information. And I came across this quote, I read the book a little bit before, but I came across this quote by, it was originally, or a reference to this basically in the article, the IEEE article, like magazine article by, I think it was Doug Bell or Doug someone, and it's about it came up in the discussion about phase versus cybernetics, basically.
Okay.
About dealing with uncertainty. And he wrote this article about, the counter-tradition to the dream of technological mastery. And it basically comes up there in that article that Doug wrote for the magazine version of it. And long story short, it's just interesting to think about it in terms of different systems and all the social and political things that are happening now. So I won't spend any more time on that than that. But there's this ties into a lot of things like AI ethics and also I'm in a discussion group with a couple sort of lab adjacent members here about not just ethics but also like the challenges of making information reliable or making truth matter in certain ways and dealing with untruth in like discussions about things. So it's interesting to see because Norbert is writing all this in like 1948, in the 1940s, and we're now in an era where this is coming out to play more. And he talks later. It's towards the bottom of that section. He talks about like how basically implies that information manipulation or like streams of information that you can't really trust or aren't actionable, how that's extremely disruptive and basically quote-unquote anti-homeostatic, and it disrupts regulation. And, there's a lot you can play off from that. And you can kind of go into okay, developmental implications of that. So that's all I'll say about that for now, but there's a lot to kind of bounce off from that section. So that's kind of what's there.
Yeah. Yeah, that sounds good. Yeah, I just saw it. I didn't really know what I was kind of thinking about it a little bit. I didn't know exactly what you're getting at.
There's a lot more discussion. If we come back to this next week when I have like my full computer access, I'll show you how there's discussion in other areas about it. So it was kind of focused on that much context. But yeah. Okay.
Yeah, we'll come back to this next week and we'll see. We'll maybe have a longer discussion about it because I think that probably does tie into the Bayes and cybernetics discussion, which we didn't really. I mean, we focused more on the Bayes and connectionist discussion because we had those papers, but I think that there's something in the first discussion too about Bayesian homeostasis and cybernetics and all that.
Yeah. If we're doing the Slack review now, I may suggest or after we talk about like the Gary Marcus stuff, just because I might have only like 10 or so minutes left before I'll be able to be sure that I can talk at that time.
Okay, well, why don't we talk about that now, and then we'll pick back up with the Slack review.
Yeah, there's some. You could go through like the posts. I think I posted a little bit about it at different points in the open chat Slack group.
The open office hours open chat.
Yeah.
Okay.
Yeah. You can probably start from the top there. Like it's. Oh, I can't do it.
Right here.
Like, before that, I think even before my nerd confirmation.
Yeah. The next decade.
Yeah. And I don't know if there's anything just about that or not. I don't know. I'll go back with that.
Oh yeah, I guess there is. Yeah.
I'll talk a little bit about that video. I'm not gonna fully finish the video, but I'm close to it. So between that video, my quick wrap is between this and I basically listened to 3 different things this week about it. I'm almost done like fully reading the paper, the actual next decade in AI paper. But that's good. I know the detail between that and the 3, like the video that's there. I mentioned the podcast, Technology and Prose podcast below in the other comment. And then I listened to, I'll listen on the way. I'm sure if you're going to listen to a podcast of Gary Marcus and Rodney Brooks, who went in together to build robust AI. And I kind of feel like I've really leveled up my big board understanding of what's going on with the overall landscape of things. And I wanted to kind of speak on that for a little bit. And the short version is, I think one of the most interesting points that hasn't really been brought up anywhere else before is, and Gary actually explicitly stated this. I mean, I'm kind of understanding Gary a little bit more overall in the sense that, he's kind of a bit of the gadfly to the deep learning stuff, and I kind of, I'm in favor of a hybrid or develop a different kind of approach to things because I care about cognitive science and I care about generalization and all of the stuff that goes into, into these things. So I have maybe a bias in it in that sense, but at the same time, I'm not 100% on. I don't think I feel like I kind of come across as a Gary Marcus fanboy to some extent, but I would say that I'm not a committed lifer to it. But I do think what I do respect about him the most is he is trying to present a lot of context for ways that things could develop differently, and he's very open and at times very candid about the reasons why there are incentives for AI to develop the way that it does. And it kind of fits, like he said, I heard some things over the last set of stuff I listened to that really fit with my kind of what happened to cognitive science approach about stuff. Because I was looking at all the AI winters and the funding disparities and what happened to linguistics and why is one of my former institutions have why is it linguistics and cognitive science? Why is it a cognitive science major or a minor in linguistics program? What are the funding waves of funding or evolution and incentive that shape the way the departments were? There's a lot that goes on there, and the most explicitly stated I've heard of it, and it's probably not anything revolutionary for people who are really in the game, especially at a at the startup level of things, and I'm obviously not there entirely, but there was commentary about how there's a lot of incentive right now for deep learning to be the king that it is, because with large companies like Facebook and Google have more data than has ever been collected about anybody, ever. Like, they are these just data collection, like black holes where they just suck in data, from every angle. And so the economic/political relationship between that and deep learning as an incentive, like, that's something we're not going to be dealing with that much in our lab here, but just like to kind of understand. I think it's really something really important and honestly political and honestly economic and whatever when people go to conferences. Like, I've opened up a set of discussions with a bunch of new people recently, and I'm starting to understand what the lines of division are. And it's not just a matter of, like, I'm not saying everybody's political and economically motivated in the sense of whatever, but like understanding how it shapes funding and shapes the trajectories of, tenures and grants and funding and office space and academic rivalries. Like, these are all part of what's going on too. So like there's reasons for why that's happening. And I don't know, this is outside the premise or the scope of what we really would be talking about in the lab, but I feel like that's actually really, I feel like many people come into these things studying either like hardware science or studying deep learning or just computer science or whatever, and there's such especially with the way things are right now, there's such there's so many forces at play that are not just a matter of science or developing your idea. And that's the way academia's been, Like, I will cite, excuse me, I'll cite the, Neil deGrasse Tyson, and it's like, what are the three major reasons that science gets funding for anything? It's like war, conquest, or like some, space rivalry thing. Like, there's very limited reasons. There's always reasons for why stuff happens. And I'm not representing that very well, but hopefully you know what I mean. Yeah. So outside of that, that's my little wrap on basically the politics behind computer science right now and deep learning and why this or that. And I shared one of my friends this is also why there's some billions of Medium articles about data science and deep learning as well, and these people doing this thing, and it just a little bit of explanation for why some things have the ubiquitous nature that they do. And that's okay. It's not a good thing or a bad thing. It's just understanding, if you're really looking at the frontier of things and you want to know where they're going, you kind of have to understand, what you're seeing is an emergent moment. And it's emergent based on the different forces that are acting upon it. So, okay, there's my complexity theory and emergence time. Outside of that, boiling it down to what's actually in the paper and what's Gary doing and everything else, it's pretty standard. There's not in the paper, I'm not quite sure how to view Gary right now in the sense of, I think he's trying to make the way wide to get a lot of people into looking at new ways of cognition and stuff. Right. And AI. And I do think that's what his main goal is, and I do think that him and Rodney Brooks are trying to do that with their company. But their company for the robust AI is not, how do you say, it's an engineering company. It's robotics based and not going to be research based necessarily. So if you don't know, Rodney Brooks is behind iRobot and Zumba. And he's done a lot of companies over the time. I didn't know, but he's a big time entrepreneur and does many companies that most of them failed. And there's an MIT associated podcast with like entrepreneurial stuff. There's just Brooks and Marcus talking about their, so it's like, I see Gary as trying to manage this company as a startup, but at the same time, he also is sort of trying to make the way wide for getting people to come into hybrid AI, basically. And he talks about hybrid AI in a few different ways. It basically comes down to, okay, it's not just going to be deep learning, probably will be deep learning. It's not just going to be symbolic, good old-fashioned AI, but that might be a factor to that. And he talks about hybrid models he used to create, like with Steven Pinker, to make, like he references often his model for like how your children learn like past tense. That means that like eating or ED, or like I walked versus I ran, like and like things like that, and that's a hybrid model supposedly, and all this other stuff. So he has this background of the next decade in the AI paper itself, and as it's kind of discussed in the video there, like he breaks it down to so like he's basically trying to do some of what I'm trying to do, or like there's a lot of overlap in the sense of what is the frontier where things can go, and here's what it can or can't be in the sense of what would a hybrid model look like, what would this model look like, what would this collection of things we need to do, what are some innates we need to work on, what are some specific cognitive mechanisms we need to be able to implement that will afford these very higher level things. And so I won't go into those detailing those things right now. I think he lays them out in the paper, and then this talk, which is kind of an update of the paper, the Beyond Patterns video. I think there's a lot we can draw from and use to inspire some of our developmental AI work, for sure. Like what are some developmental, there's a lot of overlap, and like what are some like computational developmental processes to this end, what are some ways we can incorporate this? Like I think it's really good. So like kind of like between that, and I would also mention, I posted in the Developmental AI Slack, I mentioned that there's a new publication that I'm Saffron and Inez, I forgot her name, I'll try to say her name. They're like doing this new publication, this new journal on embodied bio-AI, embodied cognition from inactive robots. And I think they're both sort of affiliated with the bio-AI stuff at like Sussex, which is what I also found earlier. But I feel like between between like all the market stuff and the other summary paper from the AI debate too, which is like neurosymbolic AI, the next generation or third wave, the Lewis Lamb paper. So like the market stuff, the Lewis Lamb paper, which is a summary. Jeff Hinton has his like how we add hierarchical layers to neural nets to kind of move it in a direction. Even like Marcus has cited Lecune as sort of an antagonist in terms of no deep learning is necessary, or we don't need these symbolic structures, and then Benjio is kind of like maybe moving closer to a hybrid position, or that's probably what AI debate 1 was, and so you kind of start to triangulate, and you get this lay of the land about stuff, and between that and what will be happening in maybe that upcoming journal, I feel like that's kind of setting the trajectory for a lot of stuff, and probably stuff that I would want to be working in myself, obviously. But I think that's and you're looking at things that are ahead, and you have I think this is going to kind of lay it out. Like there's sort of this weighted inertia towards deep learning and big data, which is like has political and economic reasons for why that's the case, and why I'm trying to be essentially a data scientist in some form, because that's where the money's at for now. And it's like, what can we do if we're interested in progressing AI or generalized AI or whatever? It's sort of like how you strategically pick what you want to focus on is going to be well received and functional. Like, find like you want to be ahead of the game, but not too far ahead of the game, and how much we have a lot of freedom, like in the lab, which is cool. But this there's a lot of a lot of things at play for this. So I think I know we would at that or take any questions about it. I'm kind of did a really quick rant and ramble from more or less sort of 5 days of listening to different viewpoints about this and putting it together here in a limited time. So,
yeah.
Thoughts?
Yeah, that's good. I mean, I was taking some notes here. It really got me thinking about some of this stuff. And it looks like we had some other discussions in the Developmental AI channel, and of course in the office hours open chat. There's a lot of stuff on the Marcus discussion that Jesse was highlighting. So there's this next decade in AI discussion to be had, and I think we should revisit this in a number of ways. The first is like going back and thinking about the AI debates. And then, maybe another way is to think about this recent submission that Jesse made to A-Life on, cognitive trajectories. It's when you submit a paper, especially if it's very short, it's never really what you want, but it gets you thinking and it gets you going. And I think that's what you did there. And I think definitely we can think about this a little bit more concretely. I think we're bringing up a lot of issues in terms of why do different fields develop the way they do? And I think that's important especially when you're drawing these maps of, different trajectories. Why do we have these strands? And sometimes, when we're doing this analysis, we have to think about, where the sort of the origin point is. And I've run across one reason I like Twitter is because it allows you get people's insights into how some idea originated. There was a post this week about, I can't remember what it was. It was some topic in AI, and it was it went back to some Japanese guy from the 70s, and everyone thought it was something that had originated in the 2010s or something like that. So it's you get these, but you see how ideas get sustained and how they get founded, and so that's all important. Looks like there's this maybe we should try to think about targeting a journal. I know we've had a couple calls in the Slack about journals and journal submissions, and I'm open to that. We'll have to talk about that more offline, but I think that's good. So you made a shared doc about this AI paper and video discussion. So this is the next decade now.
Added to it much since I did, but yeah.
Okay, so this is the one here. If people are watching on YouTube, they want to. This is in the Office Hours Slack channel here. It's pinned, so you should be able to find it. This is the video in the paper, The Next Decade in AI. In that paper you submitted to A-Life, you did cite the Mark Bedell paper from 2000, which is this thing where he puts out the open questions in AI. And so he highlights a lot of open problems, open questions. And I think it's interesting if we, I know it's a bit dated, but if we took that paper and juxtaposed it against the Marcus sort of vision, because, A-Life, a lot of those issues in the 2000 A-Life paper are still kind of open. People have been working on them, but it's a lot of those are very broad things that, and Marcus seems to be hitting on some of these things as well, like the hybrid approach. That's something that we're not going to solve in the next 5 years. That's something people will work on, but it'll be basically, a big issue in the field. And so it'd be nice to do that kind of comparison. But yeah, I think we should build on this set of collaborative notes here. So this is just on the Marcus video and paper, but if you want to add to this, here's the document. Ask Jesse for permissions for it, or and we can review it maybe next week. So that's all I have. Yeah.
Anyway, I'm gonna have to go now, so but it's good to talk, and any ideas and stuff in Slack, please reach out. I'll be able to send one after.
Yeah, no problem. Thanks for meeting, Jesse. Will you be able to stick around offline, or you have to go?
I might be able to look in a little bit, but I won't. I probably for this plan.
Okay. All right. Well, thanks for sharing everything, and all right. So I'm going to continue on for people watching on YouTube, and we're going to talk about some papers and things. And I think at this point, or we're almost done with the Slack. I think we're done with the Slack review. I just wanted to point out to people that we have, let's see, Ethics, Society, and Tech. We've got a couple things in here. And events, news, and events discussion, of course, is where we keep talking about these papers that we're submitting and things that we're, deadlines that we're hitting. So I think that's good. Now, I want to go over to this. Actually, let me share my screen. I'll just keep sharing my screen. There's this submissions document again, and I just wanted to go over this really quickly. So these are our deadlines. I just wanted to get people, keep people aware of things. So this SIG-Chi workshop, this is something that is, we need a 15-minute presentation on this. We need to finish the paper. So the paper and presentation, let's say that's due April 11, and that's coming up soon. So that's something that we'll need to, I'll probably start going over this week and getting things ready. We have some comments on the paper. It's not much, but we'll need to go over that once more. I'll probably do a lot of the editing in terms of adding references and changing some of the text, and then I'll put it up for comments. And then the same thing with slides, and we'll do a recording before April 11th. We have the evolution submissions, which are coming up. If you want to submit anything to Evolution 2021, this is the link. The submissions are open until April 15th or so. Artificial Life 2021, that actually should be updated as complete. I didn't do that last week. That is a green color here. And again, this is something that we've submitted 3 things to. We have the, actually it was the ANNs, BNNs, Cog Futures, and Developmental AI. So we shall see what the outcome of those are. I don't know when the decisions are going to be made, probably next month sometime. The conference would be this summer, so usually, you know, if you get accepted or rejected, if you get accepted, you do a camera-ready paper, and then you present at the conference. It's, again, a 15-minute thing. You know, it's probably pre-recorded because it's a virtual conference this year. And then, so we have our 8-page paper, which is, the extended abstract was 2 pages, the paper was 8 pages. We managed to get 2 papers out of that in an extended abstract, so not bad. Again, you know, if you submit somewhere and it doesn't get accepted, that doesn't mean it's over. You might want to submit it somewhere else, or you might want to expand upon it. And so definitely it's worth doing, just to start off and get the ball rolling on the idea. I recommend that, you know, even if you fail miserably in your submissions, to keep going with something. It's always worth it. So then there's this CSV Conf Submission. I haven't heard anything back on that. We have an accompanying manuscript, which we will probably, if depending on what happens with CSV conference, we will update this accordingly, and maybe like try to get something out by the actual time of the conference, although that would be in early May, so it might be a bit early, but we'll talk about that a little bit when the time comes. NeuroMatch 4 and NeuroMatch Academy are coming up. I noticed there's been some chatter in the Slack about this, and I would just like to point out that we do have a place on the organizational Slack, or the organizational GitHub for NeuroMatch, and so we need to fill this out. I was working on it yesterday or last night. I haven't gotten the talks in here, but we have a bunch of talks that are kind of archived, And then, of course, we have to revisit the Complexity of Feedback Loops project, which is this project that we had last summer. And I think it's worth revisiting. It's actually worth talking about it in the context of our Cybernetics, sort of reestablishing Cybernetics project. So that link is still active. This is, we have a bunch of stuff from last year we need to revisit. And maybe we can do a project this summer. Maybe it's more, we'll see how they do the projects this summer, but we might want to revisit this for the summer. So that's something we can work on. And then, of course, Jesse also said that he's involved in this data science education angle. And that's something that we, in this project, we actually were trying to do. We're trying to link cybernetics with the data set that we were given. And we had one data set from NeuroMatch, but we can't always get other data sets to work with. They may have new data sets this year that we can work with. So I would definitely encourage a sort of synergy between the theoretical aspect of this feedback loops project and some data analysis, some practical data analysis. And this doesn't have to be limited to NeuroMatch. We can do this in the group, in the lab. There are a number of people interested in data science. So I think that would be a good way to cut your teeth on some data science issues. So that's that. New things, the Envision conference, of course, so that is April 9th and 10th. Let me put that in here, April 9, 10. And that's coming up sooner than we think. So actually I was working on the slides last night as well as just kind of going through them. Again, this is something that I want to present on what's going on in the lab. But, this is something that needs to be updated because the last set of slides I have for that are from November 2019. And, a lot of the time it doesn't evolve that radically, but in this case it did. And so I need to update those. And I'll give people a chance to look at them and comment on them before we do the talk. I haven't heard anything back from the Cyber Cafe Scientifique thing, but this is basically what's being proposed for Envision. So that might just be the thing that we do in lieu of this Cyber Cafe. Let's see. Okay, the Gibsonian information paper, we're still waiting on the reviews. A lot of these are kind of like, I don't want to get too deeply into some of these because I don't have things to report on. This Cultural Evolution Society, this is something I found this week, I believe. This is a virtual conference. The deadline is April 30th, so they want to abstract on this. And the reason I bring this up is because it's, we talk about cultural evolution. We have some things that we could do, maybe related to CGS or some other topic. But that's something that, we can submit an abstract to, and if we get accepted, great. If we don't, well. But the deadline for that is April 30th, so it's a bit off, but I wanted people to think about it and maybe, look over the conference if you're interested. This Euler Cycles for Life, this CompleNet submission. I'm not sure we're going to do this. Just don't have the time to produce a paper by March 26th. It's 6 days off. So I would definitely not take it off the list quite yet, but I'm going to say that that's probably not going to happen. The Society in Ethics, that's on track, and we actually have, based on Jesse's information, it's this April 9th, 10th time frame again that we're aiming for a final presentation. The AI Now project, I know that was a 3/1 deadline, but I think that was flexible. It's that series of essays. So, I mean, that's something that if people want to do, it's a short essay, I think, 1,500 words, which isn't that much when you're trying to write an essay. You think it's a lot, and then you start getting into the essay. that's what I got into with the AN and BNN's paper. We're going to do a short extended abstract, and then getting into the details was decided that that's just not enough space. And sometimes it happens. You get, you have to expand your scope a bit to make it make sense. And so that's something you have to deal with in writing. So this embodied intelligence workshop, this is something that's happening this week. So we're on track for that. This proposed session is SIPS 2021. This is more of a meta-science thing. This is coming up on the 5th of April, so that's, coming up soon. It's just a proposal, so it's not so much work. This inverse generative social science workshop, I think that is not going to happen until June, but I'm not sure. They said they might postpone until June, so it's not really clear when that's going to happen. But as far as I know, we're on track with that. We have a submission, an abstract submission in there, and it's on, I guess. So there's that. The NeuroSim deadline is May 19th for an abstract, May 26th for a full paper. So I know that's a ways off, but that's a full paper you need to produce by then. I know people in the DevaWorm group have been talking about it. I don't know if anyone in this group wants to submit. Definitely if there's some ethics topic that people want to explore, that might be a good place for it. There are also the workshops. So the workshops have maybe a different timeline in terms of the submissions. You should definitely check if you want to submit to NeuroSim or one of the workshops what that deadline is. The application for interest groups for CogSci 2021. I don't know if that's something that we can do or not. We'll have to check into that more. That's May 4th, so that's a ways off. And then the positive feedback in AI paper and bias in AI paper. Those are, I think, something Krishna brought up. This Roman conference, that's tomorrow. So I'm not quite sure that's going to happen, but that's something that we had discussed. But yeah, we'll so that's okay. But so I think that's a overview of our submissions, and so I just wanted to make sure that we were, reviewing the deadlines on a regular basis. So now let's talk about. I'm going to move to the papers, and so I think we've talked a lot about these different moving parts that are in play right now, and I think people will I think we're caught up with things more or less. So I have a lot of different things in this folder. I'm not going to try to attempt to cover them all. I'm just going to cover a few of them here and there. So we talked about the open-ended challenge. I'm not sure what this is for January 2021. Oh, this is something, but I don't want to do it right now. Oops. So why don't we talk about the EI workshop program? We talked about that. Cybernetics and Development. This is a book that I found. This is an older book from 1966. So this is actually a nice book on, that's the index, but let's see if I can find the front matter here. So this is Cybernetics and Development by Michael J. Apter. So this is an older book. This is actually developmental biology. And this is Cybernetics and Development. So this is from 1966. So this is like last week we talked about cybernetics and how the language sort of evolved away from certain fields of science or stagnated in certain fields of science. Back in the 60s, 50s and 60s, maybe 70s, people talked a lot about cybernetics in some of these topics that we're talking about. So it's not like we're starting from zero, right? I told you before that sometimes people uncover these papers from 50 years ago that were written about a topic and then nothing ever followed up on it, or the language changed, or people stopped being interested in that way of thinking. And so, but these things exist nevertheless. They still exist, and some of them may be, dated, of course, but some of them may be worth following up on. So this whole book, I think I have like 8 chapters in here, and then a couple appendices. So chapter 1 in this book is the cybernetic approach. So it kind of goes through cybernetics up to like 1966, kind of talking about some of the background information from, so like in 1948, Norbert Weiner wrote a classic book on cybernetics, and then this author considers that book, but also sort of the roots of cybernetics before it. So there's some background on the subject. It's well covered, but there's a lot of stuff that's, started sort of in the Second World War. So it was kind of like what Jesse was talking about earlier with respect to, what drives technological innovation. One of those things is war. And of course, World War II drove a lot of innovation. It drove, like a lot of physics. It drove a lot of engineering, and I think cybernetics really kind of grew out of that, perhaps. Looks like a lot of stuff in the early years of the Second World War. You had a lot of people moving around the world because the Nazis had expelled a lot of the Jewish scientists. Some of the German scientists left as well. And so there were a lot of people out there. The United States and some of the Allies didn't want them to fall into the wrong hands, so to speak, so they brought them into the academic systems and gave them funding. So they were working on things like the atomic bomb, which was, of course, a horribly destructive tool, but at the time, it's not like it was something that was actually seen as a good thing or a better alternative. And so they had people working on this, and so these are sort of the roots of cybernetics historically. So just as an aside here, one of the most important papers during this period is called Automata Studies, or Automata Studies, I guess. And this is, again, there were a lot of books published. Ashby published a lot of stuff in the 50s, and of course he was in England, and they had discussions there as well about, in fact, that's where the Ratio Club was based. But they had the same situation. They were an Allied power in World War II, and they had a lot of development of computation with Turing, and so that's similar thing going on there. And then, so then you have cybernetics. It's difficult to say what cybernetics is, and then he kind of enumerates what cybernetics is in sort of terms of defining the field. So this is actually maybe very interesting to Jesse in terms of this history of cybernetics. And then how do you describe it? So I love when they start these books and they kind of get into this thing that, well, the topic I'm going to cover is a mess, but I'm going to try to break it down for you, which is both good and bad. It's maybe a bad portend for the book, but a good, I think it's good to define everything up front. And so, let's see. So they had this, although physics and chemistry differ from biology in their subject matter, it can also be argued that there's another but more subtle but equally important and far-reaching difference between them, a methodological difference. And so, you're taking things in physics and chemistry and you're trying to use them in the study of biology. And of course, you can do that, but you're going to run into problems because it's a different field, but also that there are methodological differences. And sometimes that comes from, like, the subject matter itself. So biology is filled with living systems, whereas physics and chemistry are not. And so this kind of, like, fostered this development of a new way of looking at things, which was cybernetics. And so, and of course, cybernetics is applied to social sciences as well, which have many similar things, many similar traits to biology in terms of the sort of the living systems type approach, that they're not these entities where you can get exact measurements and quantities and ratios that are, there's more dynamism, especially with like natural selection and other things in the social sciences like interactions and meaning and things like that. And so this is a good first chapter. Then it turns in chapter 2 to the problems of development. So the relevance of cybernetics to development. That's something we might think about in terms of developmental AI. And this is developmental biology, but it really does, apply to development more generally. So, they kind of get into information being applied to development, and what development is, and, how we can think about it in terms of regulation. And so, this is a pretty short chapter. Chapter 3 is cybernetics and development. It sort of keeps going in that direction. It starts talking about brain-like interactions. Now when you start getting into brains, this is where you really start to get, this is really old sort of connectionism, but, this is still something that might be useful. And then development of computers, information theory, growing automata nets, which are actually maybe really kind of interesting, to go back and not think in terms of deep learning and the latest advance, but really kind of going back and thinking about how do you take a complex system like a zygote, for example, or some other thing, a zygote being a fertilized egg or seed, and apply a computational framework to it, or a computational representation of that system. So, in this case, they're using automata nets to capture this complexity. And it may or may not be the right tool, but that's what they're doing here. And so kind of going through this a little bit. And then the control of pattern, which is chapter 7. This is where they talk about a modern pattern control. So this is where they actually synthesize everything and talk about, this sort of idea of regeneration in animals and how we can understand it. And there's a conceptual framework for it that's related to the Gestalt idea in psychology. And so then he breaks it down into a logical problem. So this is again going back to that thinking about how to break this problem down. And a lot of this stuff may be dated, but it's really kind of, I think, somewhat instructive in terms of what we're kind of looking at and kind of going back to basics on it. So that's that book, and I'll share this folder with people if they want to. I can share the link. Let me share the link in the chat, but I'll share it in the Slack as well. Okay. So now I don't want to necessarily go into this today, but I wanted to go over a couple papers and kind of discuss the papers, kind of go through them, and maybe get a sense of where we are with respect to the literature today. So first thing I'm going to talk about here is this Nautilus article. This is a popular article on That Is Not How Your Brain Works, and this is Lisa Feldman Barrett. So I think this article was discussed in the Slack a little bit. Jesse had a tweet from her about someone talking about the triune brain hypothesis, which is this idea that you have a 3-layered brain, you have a lizard brain, and then you have a cognitive brain. She was pointing out to the person that, no, that's not the way the brain evolved and not the way the brain works, which is true. And so this article, I think, is a summary of that. So she actually, has written an article on this. So this basically talks about certain ways in which the brain works and doesn't work, and kind of debunking some myths. So one of the key quotes here is that brains don't work by stimulus and response. All your neurons fire at various rates all the time. So this is interesting because I think in AI we talk a lot about stimulus and response, and certainly in experimental psychology they talk about stimulus and response, at least in behaviorism they do. In cognitive science, one of the things in the cognitive revolution that sort of overturned the dogma of behaviorism was that there's this internal model in the brain that is working to process information. And so this idea of a stimulus and response, and we do this in our Bratenberg vehicles. We talk about stimulus and response as a very simple mapping between environment and the internal brain. But of course, that's not really the way brains work. In especially like human brains or mammalian brains, there's a lot of activity internally. There's a lot of stochastic activity. There's a lot of coding. So we have this. So that's one thing to sort of debunk of your thinking about the nervous system. And it's interesting that we talk, brains don't work by stimulus and response, but a lot of the ways in which we understand behavior sort of depend on that stimulus and response. In other words, we can see the brain now in the last 30 years or 40 years, but before that, people basically had to give a stimulus to the individual subject, and then the subject would respond, and a lot of that was a black box, and it still is to a large extent. But you have this, you still have this paradigm where you have, you give someone a stimulus, they respond, and this isn't, of course, the way it works in the real world. In the real world, there's a lot of interaction between you and the world. They have what they call these naturalistic settings, which are the settings that we live in, which are where you just interact with the world freely. There's no control over the stimulus. And so that's probably a better way to understand the brain, but it's not as experimentally tractable. So it's interesting how we study the brain using this, but that's actually not the way the brain works. And so this is a nice article for really kind of getting this down to very simple language and, appealing to people who might be, whose entire conception of the brain might be these sort of myths about the brain. So, this is the lizard brain thing. So this is the idea that there's this part of our brain that's the lizard brain, which apparently evolved first, and that is in control of a lot of our emotions. But that's not really the way our brains work. We have emotional centers of the brain, and but emotion is controlled by many different parts of the brain, not just this quote unquote lizard brain. I think that's an important thing to realize is that most people think of the brain, especially the human brain, in terms of functional areas. But that's not, the brain works that way to some extent. There are some areas where, like the amygdala, is involved in emotional processing, but it also does other things. And emotional processing is distributed across the brain in different areas. So this lizard brain idea is wrong. And so myth number one is that specific parts of the human brain have specific psychological jobs. And so that goes all the way back to phrenology, which is where they drew a picture of the skull, and they drew like little compartments on the skull, and that's where different high-level cognitive things resided, like judgment or honesty, which of course is not the way the brain works in any case, but like they would, they had this idea that there were little different parts of the brain for different things, and and that's of course not how the brain works at all. So that's myth number one. Maybe it's myth number two, but and then myth number two, which is her myth number two, is that your brain reacts to events in the world. So your brain doesn't just react to events in the world. And this is, again, the way we think of like our experiments. We think about this in terms of our experiments, and that's the way we design our experiments, so that we have a stimulus response, a very controlled thing. But when you're in the real world, your brain doesn't work like that. You encounter things all the time at different rates. Your brain does internal processing, and it's, there's a lot of feedback. We talk about that a lot, but, there really is feedback. And so there's a lot of things that we do, like when we see an image like this, we interpret the image, and we can interpret in different ways. And if we just had a stimulus response system, we would just respond to the stimulus and nothing more. But that's not the way our brains work. We actually interpret patterns within it, different contours and shapes, and so we can use our memory to fill in the gaps. And that's kind of what that myth is. And so then the third myth is that there's a clear dividing line between diseases of the body and diseases of the mind. So that's interesting because in this group we talk a lot about allostasis and allostatic drive and all these things, and that actually is something that is, homeostasis and allostasis is more of sort of a convention in like physiology and medicine in some of those areas, not so much in neuroscience, although people talk about it in neuroscience, but in different ways. And so I think that's interesting that she's pointing to this myth that there's this dividing line between the body and the mind. And so I think, maybe one of the reasons why this is something that goes back to Descartes, but one of the reasons this has persisted is because of the language we use in terms of the fields that study the mind. So you have a neuroscience department and you have a physiology department, and the physiology department sometimes they study the brain, sometimes they don't. It's, the structure there isn't like we're going to study the brain with the body. We're going to study the brain separately from the body. And if people want to bridge the two, they can be an adjunct faculty in one department and, do their research. And it's not, it's not the mainstream of the field necessarily. So that's something to think about it's not even that it's a myth. It's just that that's the way our study of things is set up in some ways. And so I think this last point she makes is that modern research in molecular genetics has revealed that the tree and brain idea is a myth. So I think molecular genetics is a nice place to look, to see where sort of our ideas about behavior are maybe incorrect. So we kind of come up with ideas based on one mode of investigation, like investigating behavior. And then there are other fields where they study, say, the genetic basis of something or the anatomical basis, and they come up with other ideas entirely. So one of the ways we can, I think, come to arrive at a better understanding of the brain or of biological systems is by looking at those different levels of analysis, different ways of analysis, and kind of bring those together. So that's why I kind of throughout my career, I've championed looking at molecular factors, genetic factors, and anatomical factors in conjunction with the behavioral side of things. So in developmental psychology, they have an entire, body of knowledge on, how babies learn. But babies also learn in an anatomy which is, is affected by genes and by anatomy and developing anatomy. So you have this thing that's happening underneath this learning process that people just generally don't talk about, say in something like AI, where you're trying to understand how babies learn, and you come up with a model that's sort of devoid of any sort of innate features like, genetics or evolution or anything else. And then, okay, maybe that's the way babies learn, maybe not. We don't really know what these different layers of organization, how they might sort of constrain it or enable it or whatever. So I think that's a good article to read. There's this other article here, What Nervous Systems Do. This is closely related to this. This is an adaptive behavior publication. This is from 2013. And it's something I ran across yesterday. And so it's What Nervous Systems Do, Early Evolution, Input-Output, and the Skin-Brain Thesis. So this is kind of a little bit different view on the nervous system. So nervous systems are standardly interpreted as information processing input-output devices. And of course, we just said that that's sort of a myth because that's not really the way that they work in the real world. They receive environmental information from their sensors at input. subsequently process or adjust this information, and use the result to control effectors, providing output. And we know this from our Bradenburg vehicles. There's a simple input, simple output. And what we're trying to do in the developmental Bradenburg vehicle is to make that process more complex, just by on purpose, by design, because we want to understand like how development sort of, the input-output system is a very good experimental device for making things clear, but it's also sort of a way to also sort of make things much simpler than they are. And so this is something that we have to think about. So the brain isn't really just an input-output device. This is this pathway that people have proposed, and it's somewhat true, but there's a lot of stuff going on in the brain besides this. So through conducting activity is here the key organizational feature of nervous systems. So through conducting means that things are going through other things. Like, have information that gets relayed through different parts of the nervous system. They're conducted. Maybe there's feedback. Maybe there's like transformation through conductivity. But that's basically what they're getting at here. So they propose something called through conducting activity. And this also has to do with plasticity. So, you have this thing called use-dependent plasticity, and I talk about it in the continual learning paper, where there's this, it's basically the use it or lose it hypothesis, where if some pathway is activated, it's reinforced, and if there's something that's not activated, it's de-emphasized. And so this is this through conducting activity, where things are based on, the current activity and historical activity in the brain. In this paper, we argue that this input-output interpretation is not the most fundamental feature of nervous system organization. So it's a thing, but it's not the most fundamental feature. Building on biological work of the early evolution of nervous systems, we provide an alternative proposal, the skin-brain thesis. The skin-brain thesis postulates that early nervous systems evolved to organize a new multicellular effector, muscle tissue, the primary source of animal motility. So this actually goes back, if you attend our DeVore meetings, you know that C. elegans is a very simple nervous system. And one of the things that it evolves to do, or that the developmental system sort of focuses on first, is muscle twitching. So like the C. elegans, they have muscles, of course, muscle tissue that is used to move. And one of the first things you see in a C. elegans in development is muscle twitching. And this muscle twitching is autonomous at first. So it's like these cells are excitable cells, and they sort of have their own endogenous activity, and then they get connected to the nervous system. And then that's when they start to actually, behave in predictable ways. And so, you do kind of see this in like something like C. elegans. But there is this, this interesting connection between muscle tissue and the nervous system that's a lot of people in AI say don't think about. Early nervous systems provided a new way of inducing and coordinating self-organized contractile activity across an extensive muscle surface underneath the skin. So movement isn't restricted to, and contractile activity isn't restricted to muscle and nervous systems. You see these sorts of things in cellular systems. In single cells, for example, you have contractile activity of the membrane and other components of the cells. And even in multicellular systems, you have these sort of contractile activities without any sort of nervous system or muscle. But you have muscle and nervous system control in, the organisms that evolved it, and they're kind of doing this. This is why they're engaging in this activity. The main connectivity in such nervous systems runs across the spread out effector and is transverse to sensor effector signaling, which I think means that it's like there is the sensor effector signaling, but it's also another layer of what's going on here. The SBT, therefore, constitutes a fundamental conceptual shift in understanding both nervous system operation and what nervous systems are. Nervous systems are formal spatial organizers that turn large multicellular animal bodies into dynamic self-moving units, which is to say that they're, I guess that they organize different parts of the body to move, and they exist throughout the organism. Like the ANN's, BNN's paper, we had that funky looking organism at the bottom, looked like a fish or an amphibian. That was kind of the point we were trying to make there, that there's this, this spatial organization that transcends like just the disembodied network, that the body is important, that controlling different parts of the body are important. And that's really one of the main roles of a nervous system. So if you're going to mimic a nervous system, you might also want to mimic a body, or at least that spatial diversity of control. So you're controlling things in space, and you can map it to data, but it's not something we can just ignore. At the end, we briefly discuss some theoretical connections to central tissues within the behavioral, cognitive, and neurosciences. So this is a good paper, I think, if you're interested in what brains maybe are, why they exist, and this is a very different view. Oh, hey, look, they bring up Bradenburg vehicles in here. That's great. So in the limiting case, they talk about Bradenburg vehicles as the limiting case, which is true. Bradenburg vehicles are actually something they call a toy model, which means that they're there to demonstrate a principle instead of trying to actually simulate the highest level of intelligence that it can. It's just a model system. But of course, we've been working on this in our group to make this less a toy model and more of something that we can build on top of in terms of complexity. So, and it's interesting that they bring up this Bradenburg vehicle because, and here we are with our Bradenburg vehicle. So in a Bradenburg vehicle, the vehicle is attracted or repulsed by a light source. And so this is the simple input-output mapping. There's this input of light, it's an output on the effector or the wheels, and in this case, the neural control is very simple. It's just wires that map to an effector. Maybe there's some crosstalk here, but that's it. And that's, which means interference between the signals. But that's it. And that's very simple. In our developmental Bradenburg vehicles, we made this into a layered set of neural connections. And, in adding these in is one aspect of the developmental process. Another aspect is building complexity of behavior so that this light source is, something that you're either attracted or repulsed by. But as you add in neurons, adding connections inside, you begin to see that you can get more complex behaviors, like navigation behaviors, or, comparator behaviors, or even relativistic behaviors. Well, comparing one point of view against another point of view in another vehicle. But those aren't going to behave in exactly the same way, and that depending on their orientation to the light source, perhaps, they behave differently. And so, this is all this kind of goes through a lot of this, a lot of these ideas. I think it's an interesting idea. They actually talk here also about non-neuronal nervous systems. So they talk about sponges, which actually have things called synaptia, which are what muscle is. Synaptia are these tissues that have there are a number of cells that are basically fused together. So they have multiple nuclei, but they're tissues that do things. And we think of muscle as a synaptium, but also they're also conducting systems in sponges. And also they're collections of cells that are connected by their cytoplasm. So, they have that sort of collective behavior aspect to it. And then plants also use action potentials for signaling. And there's been a lot of work on that as well. So, the boundary between what a neuron is and what another generic cell is, sometimes it's a little bit blurry as to what that boundary is. So even in those cases, you have this, you can't necessarily make distinctions like maybe people think that they can. So we have to keep that in mind when we do our modeling, that there's a lot of complexity in the biology here, and that we need to really kind of think through what we want to represent in our models. And so this kind of gets onto some of this endogenous activity. So, an input-output system like the Bradenburg vehicle, you just have something coming in to the vehicle, and then there's an output through the effector, and that's it. In real brains, or even in our own developmental models, you have endogenous activity. So maybe a neuron just starts to become active and generate just random action potentials. And then if it's connected to a network, and actually do things like it can suppress activity in a circuit, it can modulate activity in a circuit, all without any input from the environment. But of course, environmental inputs are processed by the brain, so that's a mix of the two. And so that's how you really kind of get a really rich nervous system. And this is a nerve net in a hydra. So this is a marine invertebrate. And this is the nerve net. So this is a little bit different way of having a nervous system. This is where you have a net of nerve cells, and they all there's propagation across this network. And it's far different from a central nervous system, although they're like centers in this network. It's definitely definitely a different way of thinking about AI. And I think they've had this actually at Neuromatch. They had a talk on hydra nerve nets, and so the idea there was to get people who maybe are AI centric to think more about these other types of nervous systems. And so definitely that's another way to think about nervous systems. It's very different from our deep learning models. And so, yeah, they go through a lot of stuff in this paper. I would definitely look into it if you were interested. What other articles do we want to talk about today? Actually, this is one here, which is this Hinton paper, and we missed this last time because we didn't have time for it. We did talk about it in our discussion on, I can't remember if it was last week or the week before. It was probably the week before, where we talked about connectionism and Bayesianism. And this is also something that was cited in the ANN BNN paper. And so this is the idea that you have these connectionist networks that, again, are not necessarily differentiated, that kind of, serve as input-output devices. So you input data, you output patterns, and they're sort of these homogeneous networks, or at least homogeneous in the sense that there's no specification of different cell types or, connective modules or any of that. You just put it into this layered network. You have layers, of course, but other than that, you don't have a lot of structure. And so what Jeff Hinton is doing here is he's introducing a thought experiment to talk about like hierarchies and the ways we might organize neural networks beyond just kind of like introducing this homogeneous standard model. So this paper does not describe a working system, I like honesty. Instead, it presents a single idea about a representation which allows advances made by several different groups to be combined into an imaginary system called GLOM. And that's the acronym. The advances include transformers, neural fields, contrastive representation learning, distillation, and capsules, which are just like different techniques that people are using. GLOM answers the question, how can a neural network with a fixed architecture parse an image into a part-whole hierarchy, which has a different structure for each image? The idea is to simply use islands of identical vectors to represent the nodes in the parse tree. If GLOM can be made to work, it should significantly improve the interpretability of the representations produced by transformer-like systems when applied to vision or language. So this kind of goes through, this is actually more about like transforming stimulus or stimuli into different, sort of having like an interpretable model of how these things are decomposed. So he doesn't really go as far as like I would like to see, so glom is derived from the slang glom together, which may derive from the word agglomerate. So it's actually not an acronym, it's part of a slang term, but yeah. So this is actually kind of a representation. So this isn't really making the network modular. It's a way to like interpret a lot of this sort of functional behavior of the network. But nevertheless, it's like, that's basically the direction he's going in. So even though this paper is primarily concerned with the perception of a single static image, glom is most easily understood as a pipeline for processing a sequence of frames. So a static image will be treated as a sequence of identical frames. Glom is composed of a large number of columns, which all use exactly the same weights. Each column is a stack of spatially local autoencoders that learn multiple levels of representation of what is happening in the small image patch. Each autoencoder transforms the embedding at one level into the embedding at an adjacent level using multi-layered bottom-up encoder and a multi-layered top-down encoder. So these levels correspond to levels in a part-whole hierarchy. So when showing the image of a face, a single column might converge on embedding vectors representing a nostril, a nose, a face, and a person. Figure 1 shows how the embeddings at different levels interact in a single column. So this is figure 1 here, somewhere down here. Yeah, here. Oh, that's figure 2. Figure 1 is here. So this is the idea here. These are maybe the concepts or the features, and then these are the levels that are used to encode this, and then so you can see how this works. This is modularizing the feature space, and so the network isn't like explicitly structured, but it's basically going in that direction. So at each discrete time and in each column separately, the embedding at a level is updated to be the weighted average of 4 contributions. The prediction produced by the bottom-up neural network acting on the embedding at a level below at the previous time. The prediction produced by the top-down neural net acting on an embedding at the level above the previous time. The embedding vector at the previous time step. And the attention-weighted average of the embeddings at the same level in nearby columns at the previous time. So they're kind of incorporating feedback. They're incorporating attention, which is this selective feature extraction of the stimulus, and they're bringing this together into a top-down and bottom-up system. So like there's this idea in cognition that you have bottom-up processing, which is sort of learning how features emerge, and top-down, which is sort of imposing order on an image. And so they incorporate both of these in this paper. So this is an interesting paper. I hadn't read it fully, so I think I understand it a little bit better now. But I think it's basically, I think something that, I don't know, it's maybe above what we want to do in terms of developmental AI, but it's definitely an interesting sort of thought experiment. Let's see what else we want to talk about here. What is this paper? Well, this is something that came out, and this is more, I think, for the Devorn group, but this is growing 3D artifacts in functional machines with neurocellular automata. So this is a paper on three-dimensional cellular automata that just came out. I think this may be a life submission. Yeah, I'm not going to go over it too much. I'm just going to show some of the papers here, or some of the images. So this is a 3D cellular automata, neurocellular automata, which actually has, it combines neural networks and cellular automata into a single model, and then it allows you to model things using this sort of, this array of cells. And so this is actually something where they're looking at modeling development. I think they're trying to get biological pattern formation is what I think they're trying to simulate here. But this is definitely a good advance in this area. There's something called neurocellular automata, which are where CAs that replace the update rules with a neural network are referred to as neurocellular automata. So cellular automata have these update rules. So you have the cells that are arrayed in parallel, and then they're updated based on their current state. What you do is you replace that with a neural network, and that's what you get with a neurocellular automata. That's why they call it. It's just like you have a neural network connected to a cellular automata, and there are a lot of different variations on this. So Nichelle et al. Replaces the update process of CAs with a continuously evolved compositional pattern producing network to replicate simple 2D patterns. So the primary inspiration for our work is this paper from 2020 where a neurocellular automata learns to generate specific 2D images starting from a single pixel. So it's very developmental in nature. And they're basically simulating this morphogenetic process of things being built up from a single cell and generated to some complex object. And they're doing this in Minecraft, which I think is really cool. They're generating these different entities in Minecraft, like apartment blocks, trees, mini castles, caterpillars, and they're using these different they're putting their data in here. So they represent a Minecraft entity as a 3D grid of cells, and then they're just they reproduce the mechanism for cells' living status. Each cell has an alive channel with an alpha value, and then they're able to emerge these patterns. So they're able to train the network to produce these patterns in the cellular automata. They train the neural network to do this. So it's a kind of an interesting approach to object generation. And they have an EvoCraft environment. So they have an EvoCraft API. So if you're interested in this interacting with Minecraft, this would be a good way to do it. We haven't talked about Minecraft too much in this group, but this is something that is potentially an interesting platform for doing different things in, both in terms of like human interaction, but also in things like 3D modeling and things like that. So I think that's, maybe I want to go one more paper here. Trying to make a decision here on this. I think I'll talk about this one. Optimization in the history of science. I know we were talking about this earlier. Oh, I can't open it, so we're not going to talk about it. Let's see. Why don't we talk about this one here? What's wrong with evolutionary causation? So this is another sort of philosophical paper. This review essay reflects on recent discussions in evolutionary biology and philosophy of science on the central causes of evolution and the structure of causal explanations in evolutionary theory. In this debate, it has been argued that our view of evolutionary causation should be rethought by including more seriously developmental causes and causes of the individual acting organism. So this is tying in behavior, but also in development. I used Tobias Uller's and Kevin Lalonde's volume, Evolutionary Causation, as well as recent reviews of it, as a starting point to reflect on the causal role of agency, individuality, and the environment in evolution. In addition, I critically discussed classical philosophical frameworks of theory change. So we talked about this last week with, paradigms for looking at how theories change over time. So they look at Popper, Kuhn, and Lakatos. They use them to understand changing views of evolutionary causation. So they kind of go into causality and evolution being problematic, that it's hard to understand when something is caused by natural selection or by evolution versus not. And so, like any other set of problems, causality is always very hard. This critical stance has been spelled out in at least 5 different ways. It has been argued that natural selection has no or merely little causal power in evolution. Natural selection cannot explain all evolutionarily relevant processes. The ultimate proximate distinction includes developmental causes from evolutionary explanations. And natural selection is not a causal force working on the levels of populations. So it's maybe a statistical epiphenomenon. So that's something that, these are all things that are kind of critiques of causality in evolution. And so they kind of go on through here and they kind of address the problem, talking about some of the more recent evolutionary descriptions, or things like extended phenotypes and niche construction, looking at things like developmental plasticity in evolution and things like that. And so these kind of lead us to this idea of evolutionary causality. So I think this paper, it kind of gets into individuals' agency and environments. So these are all topics that we're dealing with the Developmental AI framework. I think that's a good tie-in to sort of what we're doing with the Developmental AI side, particularly like dealing with sort of the meta aspect of our agents and what they're doing in terms of their individuality, in terms of their environments. They cite Godfrey Smith, which is, I think, when you're talking about agents, that's something you should cite. So this gets into teleology, a lot of interesting stuff. So I think this is another thing here is another question this volume triggers is whether the views on evolutionary causation presented here impose some kind of theory change to the field. Theory change has been one of the most debated topics in the history of philosophy of science. So in the 20th century, it was very salient with the work of Popper, Kuhn, and Lakatos. And, there are different ways that people have viewed this. We talked about this last week in terms of like phase transitions and in terms of sandpile models and other things that might explain like some of these processes more sort of theoretically. But, there are a lot of ways to think about like how theories change, not just through that sort of, paradigm shift type model. But so, we have to think about all these. When we think about the trajectory, say, of cognitive science, I think we have to think about theory change as well, because that's important. Why do people change their minds about different trajectories? Why do people go down different pathways? Are they constrained by the current information, or are they constrained by their own sort of epistemological setting? That's one of the things we have to think about. So they actually get into some of these sort of ideas with respect to natural selection. So this is a very, detailed set of examples here, but I think it gives you a good idea of what's going on here. So they contrast, it's like, straight on evolutionary theory with sort of a developmentalist view of evolution. So, they get these, they look at how these different views of evolution are given different statuses and thought of in different ways. And so, I definitely think this is good if you're interested in this idea of, like trajectories of different theories in different fields of study. So I would definitely look at this paper. And I don't know if this paper that I just showed on this optimization in the history of science is, it's available. I can't preview it here, but it's basically this idea that in science we have this idea that things should be optimized, and certainly we talk about it in deep learning and in machine learning, that everything has to be optimized according to an optimization parameter or some sort of energy minimization or something like that. But that idea is not like, it's something that we do in science, but it's not the only alternative. In fact, optimization thinking has been something that we've approached rather recently. And so this kind of goes through the history of science and how optimization has been thought of and how it's become dominant. But again, natural systems, we study them, we kind of come up with the best explanations, and optimization seems to be where everyone's been headed in the last maybe 50 years or so. But that doesn't mean that that's the only alternative. That we might have, evolution actually is famous for examples of suboptimality, or things that are very, phenotypes that are very convoluted with respect to like the most optimal solution. So, there are a number of systems in biology, like the retina, for example, that aren't really optimal. I mean, they could be optimized better, but they're not. And so why is that? We think about these things in terms of optimization, in terms of like, optimizing our system so that, there's a minimal energy solution to things. But that's not all the way all natural systems work. And so I bring that up because that's a sort of a article of faith in the ML and deep learning literature that may not necessarily be true. Next week, I hope to present on, it looks like Jesse had to leave, but for those of you on YouTube, next week I'm going to present on, or I might present, I'm not sure, on suboptimality and approaches to suboptimality using cybernetic modeling. And so I hope to, if you have any questions about things that we've talked about in this meeting, or things that maybe you're thinking about doing, or discussions you want to have, please go to our Slack. If you go to our most recent blog post, you'll see that there's a link to joining our Slack if you don't belong to our Slack, or if you're in our Slack, please become active and ask your questions. So thank you for joining. I'll put a link to these all these papers on our Slack, and maybe put some of those papers in the Twitter feed from our lab for this meeting. And everyone have a good week. Talk to you later. Bye.